everyone. I am Dr. Shanthi, Assistant Professor, Department of Mathematics. Today we are going to see about projectiles, which comes under dynamics, and how a particle has been projected on a ground and how it behaves, and all the properties we are going to see in the subsequent slides. To start with, we just see what is actually a projectile is. So as we all know, we have a body, and if you project the body, definitely it travels in the space, it goes and hits the ground. So that's what we call it as a projectile. A particle or body projected, just project it and it's going to hit the ground, and the path, and we will see what actually the path is. Throwing a particle, projecting a particle is actually called as how the body projected. A particle or body projected is called as a projectile. And once a body has been projected, it goes and hits the ground. So once it hits the ground, and we are just very much concerned about how the path is. What is that path it has traced? If you could see, the path pursued by a projectile is called the trajectory of the projectile. The path of the projectile, we are going to call it as the trajectory, and that has been called as the path pursued by a projectile is called the trajectory of the projectile. Okay. And another one is called as a horizontal range. What is a horizontal range? We are at a point, starting point. From that point we are throwing an object, and that object hits the ground at the point, say A. And that OA, which lies on the same horizontal plane, that line is called as the horizontal range. We see an official definition of this. If O is the point of projection and if A is the point at which the projectile hits the horizontal plane through A. Through A is very important. The point O and the point A lies on the same horizontal plane. That is very much important. We have to make a note of this. Then that OA is called as a horizontal range. And next is range on an inclined plane. Previously what we have seen is, we have seen range on an horizontal plane. All that happens on the horizontal plane. Now we are going to see the range on an inclined plane. That is a kind of in the usual plane, you have an inclined plane. The plane will have some kind of inclination to the horizontal, and you are throwing the object standing on an inclined plane and it hits the target on the inclined plane. So in the inclined plane you have to see what is the range. So no more it is called as a horizontal range. Horizontal range is over. Now we are going to find out the range on an inclined plane. For that, suppose OA is a line of greater slope on an inclined plane. If a particle projected from O hits on OA at B, then OB is the range of on an inclined plane. All that we can see using a diagram. Once the diagram is ready with us, you can see all that in a very clear manner. Now we will see, as we have seen in the definition, we have seen trajectory. What is trajectory? The path of the projectile. Okay, how the path of the projectile? It is nothing but a parabola. We are going to see the path of the projectile is a parabola. That is the trajectory. The path it has formed, it is in the shape of a parabola. We are going to prove that actually how it is in the form of a parabola. And you can see this using the diagram. See the diagram? See the diagram? Actually, we are starting from O. The point O is a point of projection. We are throwing the object. The object hits the ground at A. You can see A. That OA lies on the same horizontal plane, and that OA is the horizontal range. So, and once you throw the object, you need some velocity. That velocity we call it as U. I mean the initial velocity. That velocity, if you happen to check, it is inclined at an angle alpha with the horizontal. So all that we need to consider. So once we have, see, this is the very typical picture of a projectile. Starting point is O and hitting the target is A. Initial velocity is U. It makes an angle alpha with the horizontal. And what is P? P is a point at time t. Okay, the point P is x comma y. That is, at time t, the x distance covered is x, the y distance covered we call it as y. Okay, actually in this we are going to show that the path is nothing but a parabola. We all know the equation of the parabola. Let us proceed with this knowledge. And all these things are concepts. How do we take it as? Suppose a particle of mass m is projected. We have the diagram, and for that diagram we have this kind of description. Suppose a particle of mass m is projected from a point O with a speed u in a direction which makes an angle alpha with the horizontal. All that I have explained using the diagram itself. Let the particle hit the horizontal plane through O at A, and this also we know this OA is nothing but our horizontal range. Choose OA as x-axis and the upward vertical line through O as a y-axis. Okay, we are going to choose the x-axis as OA and the y-axis as shown in the figure. As I told you, P is any point at time t. Then the horizontal and vertical displacements of the particle at time t or xy, we need to find out this. And one important thing we should keep it in mind here, throughout this chapter, when a particle has been projected, we are just considering the particle is going to form a path that is nothing but the parabola, but once the particle is projected, is going to hit the ground only with the help of gravity and not otherwise. In the sense, the air resistance, all those things are not considered. We consider those entities to be negligible. We consider only gravity. So that's what we are going to see here. Since Earth's gravity is the only force on the projectile, the horizontal and upward vertical components of the acceleration are 0 and minus g. Okay, we know that the horizontal component of velocity is always constant, which is the initial component, which is nothing but u cos alpha. Why the horizontal component of velocity is always constant is, through horizontal we are doing nothing, no gravity, nothing. Once it is vertically traveling, it comes down with the help of gravity. As far as horizontal component is concerned, it is always a constant, thoroughly remains a constant throughout our chapter, and which is nothing but u cos alpha. So what is our horizontal displacement in time t? Horizontal displacement, typical displacement formula, x is velocity into time. Velocity here we go for the velocity component u cos alpha, time t we call it as t. So we keep x as u cos alpha into t. Fine. Next is we are going for the upward vertical displacement. For that we need to work on it. For the upward vertical displacement during the motion of the particle from O to P. From O to P, we are traveling in the upward sense. The projectile is traveling in the upward sense. So what do we have to consider? We take the initial velocity. What is the initial velocity? U. Not only u has been bent in the vertical direction, that is in the j direction. So the component that side is u sin alpha, or else you can call it as u cos 90 minus alpha. Again you will get u sin alpha. What is the acceleration? Acceleration is generally speaking g, but we are traveling in the upward direction, so we have it as minus g. Time is t. So distance traveled, we just call it as u, y. So what is the formula which we are going to use? S is ut plus half at squared. This formula you are quite familiar with. So I am taking that formula. So what is the distance? In the place of S I will substitute y. In the place of u, initial velocity I call it as u sin alpha. Time is t. And half of your acceleration is minus g, that is why you are getting a minus sign, minus 1 by 2 gt squared. So what is your upward vertical displacement? Finally your y is u sin alpha t minus half gt squared. So keeping this in mind, so 1 and 2 I have, these are the parametric equations of the trajectory. So I have 1 and I have x and I have 1. Okay, what I am going to do is, just one second, I will just travel back. What is x? X is equal to u cos alpha into t. From this you can very easily calculate t. What is t? X by u cos alpha. The same thing I am going to substitute in y. What is y? U sin alpha t minus half gt squared. So just in the place of t, substitute x by u cos alpha, and you can do the calculations, and finally you happen to get y is x tan alpha minus gx squared by 2 u squared into cos squared alpha. Okay, that is equation 3. Okay, that is the equation of the trajectory. In the sense, y is x tan alpha minus gx squared by 2u squared cos squared alpha is the equation of the trajectory. And let us derive at the conclusion by seeing this. How can we say it is a parabola? That is the next argument. We will see this. Equation 3 is of the form, if we happen to check that with this equation, ax squared plus 2hxy plus by squared is equal to 0, we will start comparing equation 3 with ax squared and we will find out what is a, what is h and what is b. Just x squared coefficient is a. So come over here, equation 3, what is x squared coordinate? So likewise, for each and everything you can check, and you happen to get a is minus g by 2u squared cos squared alpha, and you happen to check the coefficient h, it is nothing but 0, and the coefficient b is nothing but 0. So equation 3 is a second degree equation satisfying the relation h squared minus ab is equal to 0. If you find out h squared minus ab is equal to 0, h squared is 0. And what is A? You have a quantity. What is B? 0. Anything by 0 is 0. So finally you end up with h squared minus AB is 0, which is nothing but the equation which represents a parabola. It's nothing but for a second degree equation of the form ax squared plus 2hxy plus by squared is equal to 0. If you happen to consider come at a relation h squared minus AB is equal to 0, definitely we end up with the concept that it represents, that second degree equation represents a parabola. So equation 3, which is nothing but the trajectory, what we have got out of this path of the projectile, that trajectory is nothing but a parabola. So I can now very well say equation 3 represents the equation of the trajectory, which is nothing but the parabola, and that is what we want. Thank you.